starting a new chapter, starting a new semester. Life is good. Not the most funnest chapter in the world, but probably one of the more important chapters we'll talk about. It's something that you're going to use more in other math classes than just about anything else that we cover in this class. So, not real exciting, however, extremely important. So, we'll start with a simple question. Mary,
Oh, great.
what's a ratio?
Can I like give you like examples?
You could, yeah, sure.
Like, isn't it like 1 to 2? No.
You're talking.
Isn't like a fraction one?
Like a fraction? 1 over 2?
Yeah, and isn't it like 1? Those colon things.
Those colon things. There is only one of them. It's called a colon. Yes.
Okay. And then it's like a 2, and then is there a comma one?
No, that would be an ordered pair.
Yeah, that's all I remember.
That's all you remember. So you
Or
have
is it like you say like 1 and then you put the 2,
right.
like T-O, and then a 2?
Okay.
Yeah.
So those are ways of expressing ratios?
That's why I know.
That's what you know.
Yeah.
But you don't know what a ratio is.
I mean, sure.
Sure you don't know? Or sure you know?
I mean, it's hard to explain my thoughts right now.
Why,
I don't know.
Breakdown or something?
Can we like call someone else?
I had a breakdown.
Thank you, Sherry. That's all you got, Mary?
Yes. Can I call in someone else?
No.
Dang it.
Megan, what do you got for me? What's a ratio?
I don't know.
Can you also give me an example, Megan?
1 to 3.
Okay.
Whoa.
Okay, good. So this could go on for days. 1 to 4. What do you got?
Comparing two numbers.
Comparing two numbers.
Comparing two things.
Comparing two things. Things or numbers? Well, numbers are things. All numbers are things, but not all things are numbers. What do you want to go with?
Things.
Things. You sure?
I'm positive.
Wow. How weird is that?
What?
Wow.
Did you cheat?
Nope.
Yeah.
Okay. And as Mary pointed out, well, no, she didn't really give me examples of ratios. She just gave me different ways to express ratios, which we'll get to in the following slide. But we could look at different ratios. Madeline, what things would you like to compare for a ratio?
Numbers.
Just numbers.
Okay.
2 to 7.
Okay, dog and a cat.
Dogs to cats. Okay, how many people have dogs at home? Raise your hand. Keep them up high so I can count. 3, 4, 5, 6, 7, 8, 9. Good. Put your hands down. How many people have cats at home? That's right.
Kill your cat.
2. 9 to 2. Megan, you have both? Do you also have birds?
No.
You have a bird?
How
How many people have birds at home?
I do in my garden.
You do in your garden. Thanks for sharing. Okay.
So are there any birds right now?
So we could start with what Mary started with by just comparing numbers. Those things could be numbers, or we could compare things, like Madeline wanted to compare dogs to cats, which was 9 to 2.
Two birds to one.
You could also compare boys to girls. You could compare freshmen to seniors. You could compare wingspan to height. You know what your wingspan is, right?
Yeah.
Yeah, it's the same as your height, for the most part.
I feel like that.
All right, so Mary already did this for us. Thank you, Mary. We could do it as a fraction. Those fractions must always be simplified. If it's 10 dogs to 5 cats, don't tell me 10 fifths. Tell me 2, or 2 over 1. You could do it separated with the colons, or you could use the word 2. Well done, Mary. You hit on all 3.
Yeah, very
Good job. Most commonly, we're going to use the fraction thing. Okay, we good? Got ratios under control?
Yeah.
Awesome. First example, perimeter of a rectangle is 60 centimeters. The ratio of the length to the width is 3 to 2. Find the area of the rectangle. Go. You might want to start by drawing a picture if you're a visual learner. And guess and check is not a viable solution. Little space for you. Clean the desk. Any answers? All right. What do we know? Other than that cleaner stinks.
Yeah,
Yeah, it does.
Smells like a pine forest.
I don't like it.
By the way, this is called an extended ratio problem. It doesn't tell us that the length and width are 3 and 2. That would make no sense because then the perimeter would just be 3 plus 3 plus 2 plus 2, which would be 10. However, it does tell us that the ratio between the sides is 3 to 2. So let's suppose I had a rectangle that had sides of 12 and 5. Then the ratio, bad example, 12 and 4, then the ratio would be 3 to 1. So there is some factor in here that allows us to multiply those numbers together to get us 60. Therefore, let's call that, well, if you don't know the value of something, what do we normally call it? X, good. So then how long is that rectangle? I'm sorry?
3x.
3x. How tall or how wide is that? Well, we did wide, whatever, length and width. Its length is 3x. How wide is it?
2x.
2x. And what do you know about those lengths? If one side is 3x, how long is the side opposite that? 3x. And if one side is 2x, how long is the side opposite it? 2x. And what do you know about all those sides added up together? They equal 60. Set up an equation and solve. And then make sure you answer the question. What's x? 6. And therefore, how long are the sides of the rectangle? 18 and 12. And what's the answer to the question?
16.
Okay, so all those questions that I just asked you are possible questions that this type of problem can ask you, and that's why I continue to say make sure you answer the question being asked. This one wants to know the area of the rectangle. So your answer is? 216 what? Centimeters squared, very good. Anybody lost on that?
I got to like the point where I had the equation which equaled 60 and then I didn't know what to do.
So your equation is 3x plus 3x plus 2x plus 2x?
Oh wait.
And we gotta add all four sides up. Question? Okay. Taking that idea, oh, by the way, there's the answer, good, all right. Taking that idea of extended ratios, you can then solve this problem. Morgan, what'd you get for x?
18.
Hold on one second. How'd you do?
Good.
Good. And what is the answer to the question?
36, 54, and 90.
How'd you do?
Good.
Perfect. Good. Question?
So is X always like that unknown top, not really the
Yeah.
triangle?
We have a name for that, which we'll get to in a little bit. Okay. Well done. Okay, so 2x plus 3x plus 5x equals 180. Solve the equation. As she said, she got x being equal to 18, plugged it back in to answer the question. Remember, the angles in a triangle add up to 180. I'm still getting people trying to add up the sides of a triangle to equal 180. That doesn't happen all the time. Okay, so now that we have now that we have ratios out of the way, it begs the next question. What's a proportion? Will? Either a definition or an example would be outstanding.
I don't know.
No idea. Nicole?
1/2 equals 3/6.
Is that your example?
Yeah.
Good, 'cause that's not a very good definition. 1/2 equals 3/6. Okay, what about 1/2 equals 5/7? Is that a proportion? It's not? Why not? Let me ask the masses. 1/2 equals 3/6. Do you agree with her that that's a proportion?
Yes.
What about 1/2 equals 5/7? Is that a proportion?
No.
Why not?
Because they don't equal.
So they have to be equal in order for them to be a proportion. Okay? I'm not agreeing or disagreeing, I'm just saying okay. So what is a proportion? What are we doing with that equation? Because it is an equation now because you put an equal sign in there, if that's how you want to work. Evan,
Comparison of two ratios.
have you guys seen this slideshow? Well done. Good, we're comparing two ratios. Based on that definition, let me ask my question again. Is 1/2 equals 5/7 a proportion? It is. However, it's not a true proportion, or it's not said to be proportional, okay, which we have here. Examples. 7 pencils cost 25 cents. How much would 400,000 pencils cost? Because of course everybody needs 400,000 pencils. 10 boys, 11 girls. How many boys would there be if there's 850 girls? And I thought I had another one on there. I don't. I have a moose though. Very deadly. There's a proportion. Okay. A over B equals C over D. And there's a reason why A and D are blue and B and C are red. A and D is called the extremes, and B and C are called the means. It refers to their locations within that proportion. So looking at that equation, A over B equals C over D, what do you think you could do with that thing, Molly? You could? How so? So A times C equals B times D? Or cross multiply, which would be, okay? Oh, by the way, that's what we talked about already. If it's a true statement, it's said to be proportional. Okay? It's still a proportion. If it's true, though, it's proportional. So 1/2 equals 3/6 is said to be proportional. 1/2 equals 5/7 is not proportional. So that thing that word or that phrase that you just used, Molly, that cross multiplying thing, the fancy term for that is the equality of cross products. I like cross multiplying better. We can multiply the means times the extremes, and as Molly said, we know that is cross multiplying. That is a viable way to solve or to simplify a proportion. And that's how we can check. If we go back to the proportion of 1/2 equals 3/6, if I cross multiply, I get 3 times 2 equals 1 times 6, and last time I checked, 6 is equal to 6. If I go back to my example, 1 over 2 equals 5 over 7, I get 10 equals 7. Not true, not proportional. You've done all this before, right? Yeah, beautiful. Let's move on. Reciprocal property. What's a reciprocal? Sheldon.
The fraction, but with the denominator and numerator switch.
Good. Okay. We're going to combine what she just said with the proportion, and what we end up with is the reciprocal property. It's based on a simple idea in algebra. Whatever you do to one side of the equation is okay, as long as you do it to the other side of the equation. So if I want to flip one side over, that's okay as long as I flip the other side over. So A over B equals C over D becomes B over A equals D over C. So if I want to compare dogs to cats, that's okay. I can also compare cats to dogs as long as I flip both sides over. You can't just flip one side over. Gotta flip both sides. Okay, examples. Hey, how much are those 400,000 pencils gonna cost? Oh boy.
Whoa.
Hey, forgot to do this. All right, while you guys are calculating, I'm going to chase a little X around the board.
It was 400,000 pencils.
400,000 pencils, correct. There we go. This seems kind of silly in an over-exaggerated problem like this, but as you're solving proportion problems, when you get done, you want to ask yourself, does that answer make sense? For instance, I should get more than 25 cents for 400,000 pencils. The amount should go up because the number of pencils went up. Not only are we looking for the right answer, but I'm also going to talk about how you should show work, because I know some of you just punch numbers in your calculator. I can't grade your calculator. So if you haven't done so, start by setting up a proportion, because I'm going to require that you show a proportion, and then show the work to solve it. Excellent, you're up. It's all ready to go. Unless you want to change colors, I have it set for red. If you'd like a different color, then by all means, click and knock yourself out. How'd you do? Is that a 14,000?
Yeah.
$14,285.71?
Yep.
A lot of money for pencils. How many of you got that answer? Raise your hand. How many of you got that answer but set up your proportion differently? What'd you do?
I flipped the numbers.
Give it to me.
7 over 0.25 equals to 14,000 over x.
Okay,
Plus multiply it.
okay. Two possibilities. Anybody got a third? No? So here we're comparing money to pencils equals money to pencils. Here we're comparing pencils to money equals pencils to money. Can we do it another way? I'll answer my own question. Yes, we can. We can compare pencils to pencils equals money to money. Those will also work. Now, the tough question is, what won't work? What proportion would be set up incorrectly? Jeff? Good. Pencils to money equals money to pencils. The thing to remember when you're setting up proportions, you either want the two top things, in other words, the fancy term for that is the numerators to be the same units and the denominators to be the same units, or you want the left side to be in the same units and the right side to be in the same units, if it's going to work out. Notice on this one I have pencils over pencils and money in the numerator, and money and pencils in the denominator, and that's not going to work. So just be careful how you set that up. Any problems? Awesome. Pretty easy. But again, make sure you set up that proportion so that you can show how to solve that. Okay. Solve that one. And again, set up a proportion. I don't care what method you want to use, but set it up and solve. Interesting answers. Paul, what'd you get?
Me?
You, Paul. Yeah, me reading.
772.
772 point.
You can't have half a person.
Well, you
You
could.
can't have- you can't have 27.
Chop them all.
Alright.
Yeah, I mean, you can. It's messy and illegal, but. So what do we do with that? Would you round up or down, Paul?
I guess
Why?
it's 7 is 3 with 5.
So you have 3/4 of a person, so you're just gonna make it into a whole person? Is
Yeah, sure.
that what you wanna go with?
Sure.
Anybody wanna argue 772? Why?
I do because just round down, it's easier.
So you're just gonna get rid of that 3/4 of a person? Like throw it in a lake or something?
The difference.
Just throw it in the
Just erase.
Okay. There is no correct answer to that problem well, let me rephrase. As far as rounding goes, it varies from problem to problem. So for instance, if I have a problem where I'm calculating how much paint I need to paint a room, and I end up with an answer of 4.5 gallons, am I gonna round up or down? What if I end up with 4.1 gallons? Do I round up or down? Why up? 0.1 is less than 0.5. Mathematically, I'd round down. Why would I round that one up?
So you got paint to paint the whole room.
Good, you need enough paint to paint the whole room. So it varies from problem to problem. In this particular example in number 2, I would accept 772 or 773, depending on how you want to handle that, how messy you want to get.
Colin, you can handle that.
Last example. Straight up, simple algebra problem. Solve that. We good?
Yep.
Hopefully you got y equals 4, yes? If you didn't get y equals 4, I'm guessing you got y equals 2. The reason I had this example on there is because you have to remember that that denominator on the left is in parentheses. So when you cross multiply, and it sounds like most of you did this, you have to distribute the 2 to the y and to the 2. So it's 2 times y and 2 times 2 equals 3y. Okay, just a quick hint there. All right, we good?
Yep.
Awesome. I think we're set. We got a moose, and it's telling you to do your homework. Okay, so let me publish day 1 on there, and then we'll be good to go.